Okay, notice I used the parentheses. Because we have so many negatives floating around, it's a very good idea to get used to working with parentheses and writing them in. And then, let's see, plus or minus the square root of what? B squared. Okay, so my B value, -4 squared. Once again, I used the parentheses. Minus 4 times my A value, which is 1, and my C value, which is -3. Let me extend that. And then all over 2 times my A value, 1. All right, not too bad. Okay, so notice all the parentheses keeps things nice and clean because we have so many negatives floating around. Let's go ahead and simplify. Okay, so equals opposite of -4 is +4. Plus or minus the square root of, ooh, that was a little close. -4 squared is 16. -4 times 1 is -4. Times a -3 is +12. And now that radical was too long. Okay, and this is all divided by 2. Okay, let's go ahead and keep simplifying. So this term right here, that's called the discriminant. So the thing under the square root is the discriminant. So let's go ahead and simplify that. It's going to be 4 plus or minus the square root of 16 times 12, 28, divided by 2. Let's continue simplifying. Is there a perfect square value in 28? Let's see, 28 is 4 times 7. 4 is a perfect square root number. Okay, we're going to go ahead and keep simplifying. Let's see. 4 plus or minus. Okay, I'm going to split this into the square root of 4 times the square root of 7. All over 2. And the square root of 4 can simplify into 2. Okay, almost there. Let's see. I can still simplify because each of these terms has an even number. So I'm going to go ahead and factor out that 2. Oops. Oh. Factoring out the 2 from the numerator. So what's left? It's going to be 2 plus or minus. That 2 is gone. We're just left with the square root of 7. And that is still over 2. And look at that. We can cancel those 2's. So canceling the 2's, and we are finally left with our final answer of 2 plus or minus the square root of 7. And rewrite the x down there. And what do you know? That is the exact same answer we got when we tried it the other way. Notice we were solving the exact same quadratic, but we were using different methods. So, as you can see, both of the methods worked. Okay, but sometimes it might be easier to use one method over the other method. So, unless you're told specifically to use a certain method, they all work. Well, most of the time they all work. The fail-safe method would be the quadratic formula. All right, so let's take a look at the last, I think, is this the last one? No, this is not the last one. Okay, this is the last one for quadratics. Ugly line. Let's take a look at the discriminant to find out how many real solutions there are. Okay, so I kind of mentioned before, the discriminant is that little thing under the radical. Okay, let's try to see if I can actually highlight this. No, that doesn't work. That wasn't a brilliant idea. Let's circle it with red. That might work better. Ah, yes, Watson, it worked. Okay, that right there, my friends, is the discriminant. Discriminant. Okay, why is it important? Well, it'll tell me how many real solutions there are. Okay, it doesn't speak, so there has to be a different way to find the answer. So what we do is when we use the discriminant, let me write that down on our page here. Wait, let's see. B squared minus 4ac. Okay. If the value underneath, so if b squared minus 4ac equals 0, then there is one solution. Okay? So, for example, remember, if this is 0, then the square root value is 0. So we would end up with some number plus or minus 0. But anything plus or minus 0 is still itself, so we'd have one solution. We have another option. If this is if b squared minus 4ac is greater than 0, so it's a positive number, we have two solutions. Ooh, I should be putting in the word real here. Sorry. And there's another option. So it can equal 0, it can be greater than 0, and it could be less than 0. So if b squared minus 4ac is less than 0, then there are no real solutions, which means we have imaginary solutions. Okay, so what we want to do is find out how many real solutions there are. How do we do that? Well, we're going to see if our discriminant equals 0, if it's greater than 0, or if it's less than 0. Okay, so our discriminant, b squared minus 4ac. What's my b value here? My b value is -2. My c value is -1. And, ooh, do I have another pen color? Purple. And my a value is 1. Okay, let's go ahead and plug those in. This equals my b value, -2 squared, minus 4 times my a value, 1, times my c value, -1. That's going to equal, that squared is 4. -4 times -1 is +4. So this equals 8. So, how many real solutions do I have? Well, since this number is greater than 0, that means we have 2 real solutions. So your answer would be there are 2 real solutions. So there are 2 real solutions. Okay. Kind of neat way to check on things there. All right, we're chugging along well here. Aha. Fractional equations, bumping up the bar a little more as we go. Okay, so, well, fractional equations, when you take a look at them, they're kind of noticeable because they contain fractions. Okay, so that's a good hint that it's a fractional equation. So how do we solve these? Well, in general, as I've said before, if we can get rid of the fractions, let's do it because it makes life simpler. So my goal is I want to get rid of the fractions. Well, how do we do this, you say? How do we do this indeed? Okay, we're going to use the lowest common denominator and then multiply across to cancel out the denominators. Okay, so plan. Stick to the plan. The plan, find the LCD, not the princess, the LCD. Then multiply across to cancel the fractions. Okay, notice we can use this fancy way of canceling the fractions because of one really important thing, the equal sign. Okay, if this was just an expression, you cannot cancel the fractions. But we can do it because it's an equation. All right, let's see, what is our LCD? Our lowest common denominator. Let's take a look at the denominators. We have this binomial, and that monomial. And none of them are the same, which means they are all going to be part of my LCD. So x plus 2, x minus 1. Now we're going to multiply that to both sides of my equation. Okay, so multiplying that to both sides of my equation. Because remember, we have the multiplicative property of equality. Ew, this is getting squishy. Okay. Ugh, that's hideous. I'm going to go ahead and write this out. So, because we have this binomial on this side, we're going to be using the distributive property to each of the terms. And I'll go ahead and write this out so you can see that a little clearer. Let's see. So, it's going to be 4 over x plus 2 times x times x plus 2 times x minus 1. Plus sign, bring it down, plus 1 over x minus 1. And then we distributed that in. So that's going to be times x plus 2 times x minus 1 equals this whole value, 4 over x times x plus 2, and x minus 1. And we can write these all over 1, make them into a fraction. You can do that to any number or term. Now let's see. Do we really end up canceling the fractions? If we do, we did our job correctly. Okay, so can we cancel something from the top and the bottom? Yep. Gone. Let's see this term. Yeah, there we go. X minus 1's cancel. And this term, the x is cancel. And in the bottom, all we have are 1s. Oh, that should be a 1 there, and a 1 there, and a 1 there. Okay, all we have are 1s. Our fractions are gone. So let's rewrite this. What is left over? 4 times x minus 1 plus 1 times x plus 2 equals 4 times x plus 2 times x minus 1. And the fractions are gone. Awesome. All right, let's see. We got a bunch of parentheses going on, so I'm going to use the distribution property, or the distributive property. Let's go ahead and multiply that out. 4x squared minus 4 plus, distribute this out, x squared plus 2x equals, and let's see, let's FOIL this out first. So that's going to be 4 times x is x squared. So first outside, minus x inside, plus 2x, and last, minus 2. Okay, and let's see. Okay, in the next line, let's simplify this side. 4x squared, combining like terms. X squared. So 4x squared plus x squared, going to be 5x squared. And then there are no x terms except for the 2x, so we'll just write 2x, and then minus 4. Okay, and then on this side, let's go ahead and use the distribution property. Distribute that 4 out. So we get 4x squared minus 4x. Ooh. Shucks, I should add those. Plus 8x minus 8. Okay, we can go ahead and simplify this side here, these like terms. Negative 4x plus 8 will be positive 4. So 5x squared plus 2x minus 4 equals 4x squared, adding the like terms, plus 4x minus 8. Whew, running out of some room here. Okay, so what do we have here? We have a quadratic, and quadratics, let's set this equal to 0. So move everybody to one side, because we're working with a quadratic here. Remember, the plan is different depending on if you're working with a quadratic or with a linear equation. And these are quadratic. How do I know? The little squares. Okay, moving everyone. It is evacuation time. Plus 8 minus 4x and minus 4x squared. All right. Now 5x squared minus 4x, x squared. 2x minus 4x minus 2x. Negative 4 plus 8, positive 4 equals 0. And let's bring this up here, using my arrow to indicate where my work is going. And I'm going to rewrite this here. Let's see, what plan should we use to solve? Well, I could do the quadratic equation, but I don't know if I want to. I could do completing the square. You know what? If this can factor, I'd prefer to factor it. So let's see. Can it factor? Factors of 4 added together give me 2. 2 and 2, those don't add to give me 2. 4 and 1, those don't add to give me 2. Darn. Okay, so we cannot factor. Let's see, what's the other plan we have? We could do... So when it looks like a trinomial, you can either do completing the square or the quadratic formula. So since I can't have you guys vote on it, I'll go ahead and let's practice completing the square. Okay, to complete the square, we need to make sure that we have our coefficient on the, our constant on the other side. So let's add 4 to both sides. X squared minus 2x equals 4. Then we have to make sure that our x squared has a positive 1, which indeed it does have. And the next step, let's find our star number to add in here. Okay, let's go ahead and do that on a sticky note. Our formula is b divided by 2 squared. That'll give me the perfect number. So take my b value, negative 2 divided by 2, square that. That'll equal, let's see, negative 2 divided by negative 2 would be negative 1. Squaring that, we get positive 1. Aha! My star number u shall make a perfect square trinomial for me. So let's go ahead and add 1. And once I do it to one side, remember we need to do it to the other side. Plus 1. And x squared minus 2x plus 1 equals 5. Okay, this will factor into x minus 1 times x minus 1 equals 5. And I have the exact identical terms, which is what I should have if this is indeed a perfect square trinomial. So we can write that as x minus 1 squared equals 5. And how do we solve that? We have a quantity squared equal to a number. Square root property, very good. Take the square root of both sides. Oop, forgot my plus or minus. Let's go ahead and do that. And when we get that, the squares cancel each other out. And with x minus 1 equals plus or minus the square root of 5. Almost there. Whew. X is almost by itself. Let's add 1 to both sides. And right in there. And we get x equals 1 plus or minus the square root of 5. 5 is simple. Can't take any perfect square out of it. So we are done. Whew. A lot of work, but we solved it. Okay, so the plan with rational equations. You want to cancel out the fractions. Okay. Next in the agenda, radical equations. The radical ones. Alrighty. So, how do you identify a radical equation? Well, best thing to look for is to see if there is a radical in your equation. Do we have that? Indeed we do, sir. Right there. There's a radical. So, what's the plan for radical equations? Plan. Get radical to one side, then square. Oh, this reminds me of one thing I forgot to do in the previous problem. Okay. I have a question for you. Let's say I found out that x equaled 1. Is there a problem with this answer? Let's go back up here to our denominators. If x equaled 1, well, that would be 1 plus 2, so that'd be 3. Nothing wrong. But look here. If x equals 1, then I have 1 minus 1, which is 0. Can I have 0 in my denominator? No. So, x is not allowed to be a solution to this problem. So that's when we would say x was extraneous, or the answer 1 was extraneous for this problem. So if I was to check this answer, would 1 plus the square root of 5 make any of these 0? And the answer is no. You can go ahead and plug them in and check, but the answer is going to be no. So these answers, or these two solutions, are perfectly fine. Okay, so sorry, forgot to mention that. Be careful. Check your fractional equations to make sure that your answer is not extraneous. Okay, make sure your answer doesn't make one of your denominators become 0.